Trigonometry, Chapter 1, Trigonometric Functions, Section 4, Using Definitions of Trig Functions, Video 2, Example, Using Reciprocal Identities. This series is based on content from Pearson's 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we categorized 6 identities previously mentioned, the reciprocal identities. Here they are. We can also summarize all 6 with these 3 products. Sine of theta times cosecant of theta is equal to 1. Cosine of theta times secant of theta is equal to 1. And tangent of theta times cotangent of theta is equal to 1. Regardless of which versions you use, you must know your reciprocal pairs. Now, there is a gimmick to help remember. That gimmick is that each pair has one cofunction. The top pair has cosecant, the middle pair has cosine, the bottom pair has cotangent. This is a gimmick that I came up with when I was learning this and tried to memorize my pairs. Each pair has one cofunction. One use of reciprocal functions is to find trigonometric values. There are many other uses, but let's start with this one. For example, find the value of cosine of theta if secant theta is equal to 5/3. Well, we use the reciprocal relationship between cosine and secant. Because we want to know what cosine equals, we're going to choose the one that starts with cosine equals 1 over secant. Replace secant of theta with 5/3. And if you don't know how to get out of a fraction situation like this, just remember that every fraction is a division problem. So 1 over 5/3 is the same as 1 divided by 5/3. And to divide by a fraction, you multiply by its reciprocal. So it becomes 1 times 3/5, which is 3/5. And if you didn't already know, you can take the reciprocal of a fraction by simply interchanging the numerator and denominator. The reciprocal of 5/3 is 3/5. Let's try one more. This one has a square root in it. Find the value of sine theta if cosecant theta equals negative square root of 12 over 2. Since sine and cosecant are reciprocals, we can instantly write this. Sine of theta equals 2 over negative square root of 12. Next, we'll rationalize the denominator. I can't recall if we've discussed rationalizing denominators yet. It simply means do something to get rid of the square root in the denominator. The classic move is to multiply both sides by that square root, which in this case means multiply both sides by the square root of 12. What it does is set up a multiplication problem in the denominator. The square root of 12 times the square root of 12 equals the square root of 144, but that's just 12. No more square root in the denominator. Now we can reduce the 2 and the 12 by 2. They become 1 and 6 respectively. Well, negative 6. And the 1 on the top can be ignored because 1 times the square root of 12 is the square root of 12. So now we appear to have a simplified answer of the square root of 12 over negative 6. But 2 comments. Number 1, you'll be tempted to reduce the 12 and the 6. Don't. You cannot reduce something inside the square root with something outside the square root. However, you can and should simplify the square root. This could have been done at the start of the problem. You can simplify it by taking the square root of 12, splitting it into the square root of 4 times the square root of 3, and then evaluate the square root of 4 and replace it with a 2. Notice that this gives us a 2 and a 6 that we can reduce again. Now we can reduce it by 2 to get 1 times the square root of 3 over negative 3, and our best looking answer is negative square root of 3 over 3. Just a quick comment. Had we simplified the square root from the start, it would have gone like this. We would have still split the square root of 12 into the square root of 4 times the square root of 3, evaluated the square root of 4 to have a 2, reduced both sides by 2 to get 1 on top and negative 1 on the bottom. Negative 1 times the square root of 3 is negative square root of 3, and then multiply both sides by the square root of 3, which would give us square root of 3 on top, square root of 9 on the bottom, and the square root of 9, of course, is 3. Put the negative in front, and we get the same answer that we had here. Negative square root of 3 over 3. Now you try. Pause the video and try the following. Number 1, if cotangent of alpha equals 3, find tangent of alpha. And number 2, if cosine of beta equals the square root of 5 over 10, find secant of beta. Here's your fair warning. If you haven't paused the video yet to try the problems, solutions in 3, 2, 1. Notice in the solution for number 2, I did go through the rationalize the denominator process, and at the end we had to reduce the fraction.